So see what there is a GitHub repository for that also, and it is updated one, right? The book is bit out in the sense there's a difference in codes.
Sorry, what?
So there is a GitHub repo for this textbook also, maintained by the author. Okay, and the codes there are new version of codes.
That's a new version in the GitHub.
Yes, yes.
Okay, okay.
Okay, so what I'll do is,
Maybe we can close it down, or then we will have
yeah,
some.
yeah. So I'll just show you, show you. I'll just show you. Window. You can see my screen. Right? You can see my screen, alright, huh?
Yeah, I can see, but you are not sharing.
I'm not sharing it. Now I'll share. Now you can see this screen. Nothing is being. You can't see.
Nothing, nothing.
Let me show you. Entire screen. Now you can see. Okay. Okay. So these are the ones. So here are the codes. Okay, chapter wise. All right. Okay.
That's a nice, no? Yeah, that's wonderful. Yeah.
So I'll put the link. Put the link here. So what we will do is we will probably all of us can look at this. This is repo, and this is the textbook. Okay. So textbook has more English into it. Repo does not have all the text. It has more text into it. So we can look at the text and we can run the program. That's how I'm thinking of. Okay. So probably this half for half. Let's target for half an hour, maximum 8:15, and after that, you should start your stuff, right?
No, I am not preparing anything today.
Okay. Okay. Then I'll go till 8:30.
Yeah, yeah, sure.
Because I was thinking that today you want to the question number 3. You're thinking of question number 3.
Yeah, see, someday somebody will not be there. No, that time I will take it.
Oh, okay. Okay.
We have the ball rolling every day, no? So,
Okay. Till 8:30, I will take. Okay. All right. So I'll show you. So till the last time, this is what is our code. So we were here till here. Okay. May I know who has joined CP?
Chandrasekhar.
Hi, this is Chandrasekhar joined.
Hello, Chandrasekhar. Hi. So were you there in the last session last week?
I was there. I will just try to follow. Yeah, you just proceed.
Okay. 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 Cool. So we are here. We have downloaded the MNIST data, which is handwritten digits. Okay. And then we have looked at this is 28 by 28 pixel. And after that we have created network architecture. Okay. TensorFlow Keras, and we have two layers, one hidden layer which is rectilinear, and another one is softmax. Okay, the final layer which is output layer. These are dense layers, means they are all nodes are connected.
Yeah, like
Okay.
this network architecture means we are just creating the layers, right? And
Yes, network architecture. So network architecture, you will define your model, which will contain the layers and also activation function. Come again?
and the number of nodes in each layer, no?
Yes, and number of nodes in each stage. Okay, and the next step is your compilation step. Okay, so first you had the data, you just played around with it, tried to understand that train has 60,000 images, test has 10,000. After exploring this compilation, network architecture we have done, then next step is compilation. Okay, compilation, you define your optimizer, your loss function, and the metric on which you would say that your model is doing good or bad. Okay,
So through
next.
we had a discussion, right? It was like backup or something.
Yes, yes, yes.
And Vinay,
Okay.
Nagesh has joined. Hi, Nagesh.
Hello, Rajesh.
Hi Vinay, hi Manoj. Good evening.
So after compilation step, Nagesh, I think you know this. After compilation step, we are preparing the data, and
Okay.
for preparing the data, we are reshaping it. Earlier, our data set was in 60,000, 28, 28, right? It was three-dimensional array, right?
Okay.
We are flattening it now 28 by 28, right? And then we are numerically making them between 0 and 1.
Okay.
Three-dimensional or is it two-dimensional? I think it's a two-dimensional, right?
It is, yeah, I mean, it is two-dimensional. Three-dimensional in the sense the array was three-dimensional because there were images, right? Array was three-dimensional in the sense that, so the NumPy array, if I show you,
Yeah, we are creating
uh,
array with the number of rows also.
yes, yes, yes. So NumPy array, each row, this shows each row, this shows each row. So two dimension, you're right, it is two dimension column by row. The third dimension was the image. So first image, second image, third image. That is, you can call it axis also, dimension, whatever, number of images. It's not three dimension in that sense, but in the sense of that.
Is that the right understanding? Because here I can see two dimensions. Can you show the shape
Yeah.
of this?
The
See,
bracket.
image is two dimension. Image is two dimension.
The bracket, no, from the bracket I think.
One second. Manoj, you are saying Nagesh,
Yeah,
right?
actually me too. The bracket, basing and brackets we can.
Okay, let us understand. Let us
confirm it.
understand one thing. Let us understand one thing. Okay?
Yeah.
So forget three dimension. It's a two dimension image. Okay. Where what I said, three dimensional array. Why? First array will be 28 by 28, two dimension. Then second image will be 28 by 28. So each image is also considered as an array. In the array, it is also considered in dimension. The image is two dimensional. Okay, sorry for
Okay,
that.
actually we are taking image in image. You mean to say for each and
No,
every.
number wise. So what
Okay.
happens if there is an array? So how do you access that? First index 0,
Correct.
right? Second index 1, third index, like that. So there are 60,000 images array wise. That's why I said array was three dimensional. You can forget image is two dimensional. Okay.
Okay.
You're clear on this. Sorry for confusion. Okay. Image is two dimensional. After that, now it is the image which was in 2 dimension has not now been flattened with 1 dimension, right? It has been flattened now, 28 by 28. Okay, but you see this is what I was talking about, another dimension, that is 60,000 images are there, right? But you can forget it. I mean, it can create confusion, right, to understand. All right. So now the next step is fitting the model. We have training images, we have training labels, we have epochs, we have batch size. These things will become clear later. Okay. Epochs, we generally have, the one pass of, going ahead and going back. That is called epoch. Okay, but let it be according to the flow of the textbook. We are not discussing it right now. We will discuss it when it comes. Right now, the focus is on to just to show how whether it is working or not. Okay, let me run this. Things will, I mean, even the optimizer, loss function, accuracy, everything will become clearer as we move ahead. You can all side by side look at the book also. We are at this page number 52 here right now. Okay, so some of the codes we are not running which are in the book, because we are following the GitHub repository which I have mentioned, which I have put it in the here. Okay.
Okay.
Now 5 epochs are done. 469. The batch size is 128. Okay. So it is run now. What is our next step? Next step is using the model to make predictions. Okay. Nagesh, can I just mute you for a second? Yeah. Okay. Please unmute whenever you want to make a point, because I cannot see the chat window. Okay. Using the model to make predictions. Here, let's make it in another. Sorry. This is not here. Test images. So we have taken test images 1 to 10. Okay, 0 to 9 in Python, right? And then we'll make predictions for 10 of them. Okay.
So what is that? We are taking 10 images for testing.
Yes. Yes.
So last 10 digits, I mean 10 images or
First and first. 0 to 9, right? 10th one will not be there, no? Okay, 1 to 10 you can say. Okay. So we will just see predictions of the first. Okay. And you can see, because it is softmax, you know, right? Softmax will give us probability for each class 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And you can say 1, 2, 3, 4, 5, 6, 7, 8. Eighth one, right? It has given minimum, the maximum probability to this. You can see, right? This is e raised to power 4. I can see this. So it is predicting it as a 8. है ना?
yeah, this is softmax output, or is it something else?
Softmax.
Oh, the softmax we are getting individual probability. It's not showing the maximum, right?
No, it won't.
But we learned in the different way, right? Softmax is giving something.
Let's see. Probably there is something else. So this is argument max. This is what, probably 7. Okay, 7. Acha, 0 is also there. Na? 0, 1, 2, 3, 4, 5, 6, 7. So, okay. So on top of softmax, you put argmax. You're right.
No, we are supposed to get from 0 to 1,
This will become run. One second. I'll just show you. Some predictions. This will be one only. That's what you want to check, na? Manoj? Okay. Guys, clear? I'm audible?
Yes, yes, audible, Vinay.
You, Samiz, I have summed everything. One second, then let me go back. Summed all the predictions. You wanted to show that you wanted to know whether all get prediction 0 means the first image. It has predicted for the first image. Yes.
How see individually they are having 1.29 point something, and how you are getting the
Okay. You are missing this now, Manoj. E raised to power minus.
oh it's a E raised to okay I missed that one yeah.
So that's why I looked it here and I could find out that it has the highest probability. 0.9. Right?
Yeah, it's giving the same thing what we studied actually.
Uh, that's why I showed you that sum here. That it is 1 point.
Okay, but when you submit it, so E is going, no, E is not there, right?
Of course, because everything is now coming at. So otherwise, it will be E here will be what 0. E, you know what is E, right? It is 10th raised to this power.
2 raised to something, right?
No, E here is exponential. It's exponential of 10. E here is E here is. Okay. Can you figure it out on your own?
Okay.
I can show you. See, this minus 0 1 means 10 raised to power minus 1. Is it clear? Now you don't have to figure out. Okay. Cool. So E means anywhere. This means what? Tell me what does this mean? 8.05 into. What is this value? Manoj? Yeah, E raised to E. What does this value mean? I told you this, no? I told this value to you.
0 1 is 5, so 5 means maybe 10 raised to 5 or what?
10 raised to minus 5. Here it is 10 raised to minus 1. 10 raised to minus 1 is 1 by 10, right? What is this?
It is 10 raised to minus 14, huh?
Yes, this multiply by 10 raised to power minus 14. This multiply by 10 raised to power minus 1 is 1 by 10, right? So 1 by 10, your decimal will move this way. Got it? Is it clear, Manoj? We can spend some more time. Okay. Is this clear, guys? The first prediction is here, right? Just now you tell me.
Yes.
Let's look at one of the predictions, and probably we will also. Okay, let's do one thing. Before this, let's look at what it really is. 7. Our model predicted 7, right? Let's just look what actually is. Oh, okay. So here it is flattened here. Actually, we cannot see this because we have flattened this. Okay, because we have flattened it here, no? That's why we cannot see the picture of it. This we saw the picture of it because we had not flattened it at that point of time earlier. Okay. Otherwise, we'll need to again download it now. We'll let it know. We'll let it away. But that's what the prediction is right now. Okay. Cool. So now if I go back to book, this is do. Okay. Now book is saying us we'll test accuracy and all this. We just check what is happening in the Git repository. Argmax 07 prediction 07. Okay, test label 07. Prediction 0 and prediction 07. It will be highest, right? I showed you, right? Prediction 07 will be this value, right? I can just show you this if you can. Right? Same value. Yeah. Okay, now we are test labels 0. Now this we can check. What is the from label we can check, right? Picture we probably don't want the picture, but we can check from the test label, right? What was the 0 label? It has to be 7. 7, right? Okay. So our prediction is correct. Okay. Evaluating the model on a new data. Now we have done prediction for some. Now let's evaluate our model. We have probably we have not checked the train accuracy, but let's find out our test accuracy. We can check our train accuracy also. It's not written here. We already know the accuracy. No? How do we know our accuracy in train accuracy? Here. See. 0.9912, 0.9931, 0.9957. So on training, this was our accuracy. Okay. And test we can see. 0.98. Okay. So this generally happens in training. You have more accuracy. In training, you have 0.99%. Here we have 98%. Okay. This generally happens because of overfitting. Okay. To learn more features in your train data, and here there is, I mean, still 98% accuracy is pretty good, but you're saying something? This is good, but in automated system, Manoj, it can go. You will require some, 6 sigma kind of fault tolerance, right? So you would, at that level, you would require accuracy of 0.99999, 99.9999%. So case by case, I mean, it depends. Okay. Now we can just have a look. See, after this,
Can I one question? So, but when we say overfitting, right, this accuracy will improve, right, when overfitting happens.
No, accuracy overfitting happens, then your model is doing well on your
okay.
training data.
Only the training.
Only training data, it will be more accurate. But when it tests, the accuracy will be disturbed for overfitting.
Okay. Yeah. So which basically means like the data. I mean the training is not done with sufficient data, right? To get that level of accuracy.
Can you take it up? Nagesh is asking. Chandrasekhar, can you take a stab at it? Can you try to explain?
Yes,
No,
yes.
what
Actually, the thing is,
Ah,
yeah, please,
yeah.
please, Chandrasekhar. The accuracy when
go ahead.
what situations that overfitting will happen means there are two conditions. So, I mean, mostly the training data. I mean, that the data what we have is not enough. In that case, what happens?
Exactly.
In that case,
that's what I was trying to say. Okay.
correct.
Okay.
Then what we see is we take less data and we fit it. Then the accuracy will be super. But when actually the testing comes, then it will deviate to. I mean,
Yes.
unexpectedly it behaves.
Got it. Yeah. Correct. Yeah.
Sometimes even
What
if
is
you
the
have
other
lots of data in train, even if you have lots of data in training, but if you train it extensively, right,
Yeah.
with that data only, then also it will overfit because it is only seeing that data and you are learning a lot of it from that data.
Yeah, actually
Yeah.
that in the final exam also we got similar case. The exam question also we got it. So when we keep on testing, I mean actually
On sample
testing
question.
on training data. Yeah. Again, we are updating the model with the same, I mean, training data again and again with the data. And one time it comes to the peak again. If you keep on testing, it goes again back. It goes back.
Correct.
So,
Correct.
Okay. So, is it clear? Shall we go ahead?
Yes. Yeah, it's clear. Yeah. Thank you.
Okay. So now the book talks about which is section 2.2, that is data representations for neural networks. If someone can fastly read this for the benefit of everyone, or if
I'll read it. Yeah. Can you just show it to the maximum? I think screen is not fitting to that. Maybe little index. Yeah. Now it's okay. So in the previous data representations for neural networks, in the previous example, we started from the data stored in multidimensional NumPy arrays, also called tensors. We started the data in multidimensional NumPy arrays, also called tensors. Tensors are the multidimensional NumPy arrays. So in general, all current machine learning systems use tensors as their basic data structure. Tensors are fundamental to the field, so fundamental that Google's TensorFlow was named after them. Google's TensorFlow. So what's a tensor? At its core, a tensor is a container for data. Almost always numerical data. A tensor is a container for a data. At the same time, it is a numerical data. So it's a container for numbers. You may be already familiar with the matrices, which are two-dimensional tensors. Tensors are generalization of matrices to an arbitrary number of dimensions. Note that the context of tensors, a dimension is often called an axis. So it may be x and y axis, we can say. That's it. So we have a two dimensions here, means one we can say that it's a scalar and one is a dimension and direction also. That's what. So that's a scalar. 0D tensors, 0-dimensional tensors are scalars. A tensor that contains only one number is called a scalar. A scalar is a tensor or 0-dimensional tensor or 0D. 0D means 0-dimensional tensor. In NumPy, a float 32 or float 64 number is called a scalar tensor or a scalar array. So it's a one-dimension, 0-dimension. You can display the number of an axis of a NumPy tensor by a n-dimensional n-dim attribute. A scalar tensor has 0 axis, n-dim equal to 0. The number of axes of a tensor is also called its rank. Here is a NumPy scalar, that is import NumPy as NP, x equal to np dot array bracket 12 and np dot array of 12 x, array of 12 x and m, that is 0.
So this I'm not doing. This is self-explanatory, right?
Yeah,
You guys,
correct. Yeah.
this we I don't need to.
Huh.
You can
The
just see,
vectors,
you type this, you will get this.
Yeah.
I mean, it just shows that, if you create an scalar that is one single number, it has 0 dimension. It is a scalar, it has 0 dimension tensor. Okay. So 1 dimension tensor is similarly, if you create an NP array, which is sort of list. A list is a 1 dimension array. You see, 1 dimension, and it's 1 dimension tensor. Okay. Has 5 entries
is it
and
like,
called a 5
is it like
dimensional vector.
a tensor is kind of synonymous to a matrix, right? In a way.
Our matrix is a 2-dimensional or 2-axis tensor.
Right. I mean, okay. So matrix can be 1 dimension, but not 0 dimension, no? Mostly.
Matrix will always be 2-dimensional.
No, it can be multiple, right? 3-dimensional matrix also is there, right? I mean.
3-dimensional array.
Array. Okay. So basically, tensor is a array. We can assume like that. Multiple dimension array.
Yes. So 2-dimensional array is your matrix. That is m rows and columns. M into n.
Yeah. Okay. Yeah. Thanks.
Vinay, can you explain once again this 0 dimension thing? It's a bit confusing and.
A single number is a 0 dimension. It does not have any dimension.
Single number. Okay.
Okay. And when you have a list, it is 1 dimension. If I would have created a matrix, how many dimensions it would have had? 2 dimensions. Okay. I would have created this array, right? For example, just to show you, let's do this.
if we have rows and columns, then it is 2-dimensional. If we have one single row of series of number, that is a 1-dimensional. If it is single number, that is a 0 dimension. In that way, I think we can. Yeah.
Array means it is
What is this NP? Fill element was 2 or 3 tuples. Got 5. NP dot array. 1 second. Why it's not showing here? 1 second. How do you define an array? Let me just check it out. Like that. Like this. Okay. X. If I want to show you X will be like this. Okay. And X dot and dim. Okay. Clear, guys?
Yes, clear.
There is some confusing thing here, but if you want to, let's read it. This vector has 5 entries, and so it's called a 5-dimensional vector. Don't confuse a 5D vector with a 5D tensor. A 5D vector has only 1 axis and 5 dimension along its axis, right? Where a 5 tensor has 5 axes. The dimensionality can denote either the number of entries along a specific axis in the case of 5D vector, or the number of axes in a tensor, confusing at times. In the latter case, it's technically more correct to talk about tensor of rank 5, right? So just I think this should be avoided.
This tensor and matrix, what is the difference?
A tensor with 2 rank is a matrix. A tensor with 0 rank is a number. A tensor with 1 rank is an array or list. A tensor with 2 rank is a matrix. A 2D tensor. Like here. An array of vector is a matrix. Vector is one dimensional tensor. Okay? Question is?
Yeah. So vector is basically a single dimension
Tensor. 1D tensor. Yes.
Right, right.
List. Call it a list also. You can call it a list.
Yeah. Usually we represent a vector by a straight line, right? So
Yes.
with a direction. So it is a straight line is a single dimension thing, right? So that way we can understand, I guess.
Yes. Yes, yes. A number line. Think
Yes.
of it as a number line. Yes.
With the direction arrow. So yeah.
With the direction, of course. Because it can have plus and negative both numbers.
Exactly.
Okay? So it has done this thing. The entries from the first axis. If we do 5 pages once, we will not be able to do. Let's try to do this. Let's see how fast we can. The entries from the first axis called rows, same thing. 3D tensors and higher dimensional tensors. Right? 3D tensors. Okay. So that's why I was saying it as 3D. That yeah, 3D. It was a 3D tensor.
So this is array and tensors are same then, right? 3-dimension array and 3-dimension array tensor, right?
I think it's same. Yes, it's synonymous. MP.array. Yes. It's so array. It seems that you do not talk in dimensionality of array in deep learning. You talk about dimensionality of tensor.
By packaging tensors in array, you can create a more dimension. In deep learning, I think we need to
Yeah.
tensor.
Yeah. So what we have done, we have this is one dimensional array or one dimensional tensor, right? This is one dimensional tensor.
That is a 2-dimensional array, no?
So after it's called 2-dimensional tensor. So let's when in deep learning, let's talk about tensor. Okay, array can be 1-dimensional tensor, array can be 2-dimensional tensor, array can be 3-dimensional tensor. All these are called array.
I think the kind of little bit synonymous, I think, array and tensor. Like 2D array, 2D array is kind of 2D.
No. So according to this book, any representation of this kind numerical is an array.
True.
Tensors are an array can have multiple type of tensors. An array can be a 2D tensor, 3D tensor, 5D tensor, like that. A 0D tensor is called scalar. That is one kind of array. 1D tensor is a vector. That is another kind of array. So everything collectively are called array.
Okay, I got it. So basically, a tensor is a kind of unit, right? Then
you can think of it like this.
Okay. So
array is a sort of common noun. Array is a common noun. Think of array as a common noun.
Okay.
Array is a common noun tree, and then in that you have 1D tensor, 2D tensor, 3D tensor. And by packing different dimensions of tensor, you can have a different dimension of tensor. For example, this is 1D tensor, right? This is 1D tensor. You have packed them together to create a 2D tensor.
But basically, this is a 2D array, right?
Again, it's nomenclature. Just think of array. Go on.
If you show the book, no? Can you show the book? There something which is confusing. See, by packing 3D tensors in an array, okay, if you pack such matrices in a new array, you obtain a 3D tensor, which you can easily. Can you check before this any information is there? They are saying if you pack matrices in a new array, it will increase.
See, basically,
If you
it's
pack
like this.
such,
No? You can, if you pack a list of single dimension array, you will get a 2D array. Same thing, same concept. Yeah,
Array and tensor is same, I think. If you pack
same. Correct. I mean, at least now for understanding, we can assume. So maybe like, yeah,
so
maybe in
this
the context
is a
of
2D
deep
array.
learning, they are using the term tensor here, I guess.
Yeah. Just think of that in deep learning, array is a common noun, and array can be a 1D tensor, 2D tensor, and like that. For
Yeah.
example, now I can pack this 2D array to create a right. So this is one matrix, and let me create another matrix. It can create 3D tensor out of it. Okay, this is two-dimensional, right? And now I'm creating a three-dimensional one. Right. Okay, let's put it like this. X, and let's make it Y. Okay. Now, what will be the dimension of this array? What dimension tensor is this? 3D tensor. Call it 3D tensor. Okay. Call it 3D tensor. Okay. Cool. This is a 3D tensor. So you can. All right. Similarly, I can keep increasing the dimensions, right? Think of it as something. This is one picture. Take another picture in front of it. This is one picture, right? One matrix, and someone has put another picture in front of it. Okay. Am I clear? From two dimension to 3 dimension, I can help you in visualization, but from 3 dimension to 4 dimension, I cannot help you in visualization also. Tell me if you have doubts, you should clear it now. Your voice is breaking, Manoj. I cannot hear you.
Okay, then go. Okay, let's go ahead.
Yes. So do not fall into trap of nomenclature. Array is an umbrella term, is a common noun. In array, you have one-dimensional tensor, two-dimensional tensor, three-dimensional tensor. Okay. For example, trees is an umbrella term. Within tree, you have grass. Okay. Think of tree as a botanical name for all plants. Or plant is an umbrella term. Within plants, you have a tree, you have a shrub, you have a hedge, you have all those things. Like that. Cool. So this is clear, guys. If more questions, let me know, or we move ahead. We have already
Fine. Yeah, it's clear.
10 minutes more. Okay. Okay, this is clear by packing Freddy. Now key attributes, if someone wants to read it. Or I mean, if you find it difficult, I would suggest Manoj has already shared the link of it. Please download it in your local so that you can read it clearly, or take a printout. Key attributes. So I'll just read this by packing 3D tensor in array. You can create a 4D tensor and so on. In deep learning, you will generally manipulate tensors that are 0 to 4D, although you may go up to 5D if you process video data. Okay. Key attributes. Someone wants to read it? Please go ahead. Yeah. Anyone else? Nagesh, Satish? I think Manoj, his voice is breaking.
It's okay. It's okay. Yeah.
Yeah, go ahead. Anyone wants to read it? Or shall we read it silently?
Yeah, I can read it. Okay, so a tensor is defined by three key attributes. Number one, number of axes, also called as rank. For instance, a 3D tensor has 3 axes and a matrix has 2 axes. This is also called the tensor's ndim in Python libraries such as NumPy. Okay, I think it is clear, right? So number of axes, basically the number of dimension and shape. So this is a tuple of integers that describes how many dimensions the tensor has along each axis. For instance, the previous matrix example has shape 3, 5, and the 3D tensor example has shape 3, 3, 5. A vector has a shape with a single element, such as 5, whereas a scalar has an empty shape. Okay. Data type, usually called D type in Python libraries. This is the type of the data contained in the tensor. For instance, a tensor's type could be float or uint, float 64, and so on. On rare occasions, you may see a char tensor. Note that string tensors don't exist in NumPy because tensors live in pre-allocated contiguous memory segments, and strings being variable length would preclude the use of this implementation.
Okay. Is it clear? For example, the previous matrix has shape 3, 5, and 3 test has shape, the vector shape is single and this empty shape. Okay, vector shape is single.
Yeah.
Tensor type could be float.
In the case of a matrix, I think the order of the matrix, right? That will be the shape, right? So 2 by 4, 2 by 3, or 2 by 6, 2 by 5, 3 by 5, like that. So that is the shape here.
One second, because tensor even pre-located on the variable and the shape has shape 3. The matrix has shape, yes. 3, 5 is order, yes. M into n, rows into column.
Yes.
Vinay, I am audible now? Or?
Yes, you are audible now.
Okay, so I think the shape of the matrix is like 2 dimension, and tensor means if there will be having multiple arrays or multiple matrix inside the array, no? Then it becomes a tensor, right? Or what?
Manoj, first of all, do not think much about array or vectors. Okay, just think a single number is a zero-dimensional tensor. Is it clear?
Single number is a 0-dimension tensor.
Okay. A single list 1, 2, 3, 4, 5 is a one-dimensional tensor. Is it clear?
Okay.
Is it clear till now?
Yeah.
A matrix.
And this one-dimension thing is also called a matrix of particular shape, right?
Just tell me one thing. Is it clear that a single number is a zero-dimensional tensor?
Yeah.
A list 1, 2, 3, 4, 5 is a one-dimensional tensor.
Okay.
A matrix is a two-dimensional tensor.
Okay.
Is it clear?
Yeah.
So, I mean, I'll just tell me what is this? It's a matrix.
Which one?
This is first row. This is second row.
Yeah, that's a matrix. Yes, right. That's a matrix.
Right? And it is two-dimensional tensor.
Two-dimensional tensor. Yeah. Two-dimensional tensor
Okay.
means two-dimensional matrix also.
Matrix is always two-dimensional, Manoj. Two-dimensional array or sorry, I'm not going to talk about this thing array. Two-dimensional tensor is called matrix. Two-dimensional matrix is two-dimensional arrangement of numbers.
I think yeah, can I got some another view. Can I?
Please go ahead.
Yeah.
And
Yeah,
do
Manoj.
not talk about array. Do not talk about array and tensor.
Yeah. I don't use that word at all. Don't worry. I don't use that word.
This is
Actually,
deep
for
learning. Deep learning terminology. Just remember that all these together are called array. That's it.
Yeah. Okay. Actually, just let us talk in terms of only numbers. Okay, and just can we let us imagine, Manoj, let us imagine to plot on x and y axis. Okay. Can we plot actually what is 1 2? If we give x equal to 1, y equal to 2, it is 1 2. It actually it can be plotted on the right side of the plot, right? X and y axis in the right side of that. X equal to 1, y equal to 2. So it is two dimensions. We have x value, we have y value also. It is two dimensions, right? In that way, if it is only x, we can't say there is dimension. So if we have too many x's, actually x multiple x's and multiple y's, it is also it is equivalent to one matrix, that is two dimension. That's it. If there is one value, either x or y, we can't say it is a two dimension. That's it. There is no dimension. We can't tell in terms of x and y. We don't know. We can't define. We can't put that value on anywhere because we don't know whether it is x value or y value. We can say that there is an x value plotting on some x-axis and there is no y value. We can't say the direction at all. So we have the scalar value. Only the scalar value is there. So we don't have any direction. So we can't say that it is a two dimension. That's it. I think yeah. Yeah.
If you have multiple numbers inside an array, it becomes two-dimensional.
Yeah, two dimensions means what it does mean. We have two x values. We have two y. Actually, we have
X and Y values.
X-axis. Two x's. Actually, we can say that is actually two dimensions means x value is there, y value is there. That is a two dimension. Two dimensions. Okay, we have multiple dimensions when happens. We have another axis, x axis, y axis, z axis. Imagine there is a z axis also, and when we plot a point, for each point there should be one x value, there should be one y value, there should be one z value. You got it, right? So x1, for example, in this array of this one, 12, 3, 6, 14, this is x value, and 5, 3, 6, 0, 620, this is y values. So it is two values.
No.
It is two dimension only, right?
One second. This is x's value. This is all rows, no? Column x and y. So
I'm telling x values, x equal to 12, x1 equal, we can say x1 equal to 12, x2 equal to 3, x3 equal to 6, x4 equal to 14. And y1 equal to 5, y2 equal to 3, y3 equal to 6, y4 equal to 20.
Correct.
If that is a three dimension, there should be another value of z, then there should be another row.
Okay, guys, actually one issue, now it's going to end, we can rejoin again, okay?
Yeah.
No, I think we should we should think more about it, and it's
Yeah.
1 hour for me also, and I need to work on something else also. So great, we will resume this. Okay.
Okay.
Thanks, Nagesh. That was interesting information.
I'll share one dimensional thing with you, one YouTube video that definitely will give an understanding. I'll check it out. Actually, I'll recall where it is there, and definitely it gives good insight of maths basics regarding dimensions especially.
This what you suggest is interesting. Okay, first row is 2, 3, that one is X, next one is Y. For X, Z, it has to
Yeah.
one more, right? Then
Yeah.
Nagesh, why don't you create a document if possible, or something like that, or video, something like that?
I'll try. Definitely. I'll create. Yeah.
If that is, I mean, if that is not much of a task, probably 2-3 minutes, and you can.
Yeah, definitely. I'll try. Yeah.
Okay. Thanks a lot, Nagesh. Thank you,
Thank you,
everyone.
Manoj. Thank you, Chandrasekhar. Thank you, Ashish.
Thank you all.
Thank you. Bye.